Well, thank you everybody for joining us. We appreciate you coming to this 3DCS and Planner webinar with Metrologic DCS. As some of you may have noticed, we have a new branding, a new name. Metrologic and DCS have merged together into one company and one team. So this is going to showcase a couple of the benefits that you as our customers and colleagues are going to experience from this merger and from us being closer together. Now, as a safety first company, please make sure you're aware of any of your emergency exits and you are wearing any necessary safety equipment. Our mission together, Metrologic DCS, to of course empower manufacturers to achieve digital, real time, and data driven quality. So, we're going to be doing this by combining our solutions together and creating new connections so that you can share information from one end to the other of your product lifecycle. Our core values are winning together, curiosity, responsibility, and customer focus. So, what's really important here is you'll see that we are still going to be as customer focused as we were before. So, with us merging, you now have access to even more expertise than you did previously. And we'll see that we are still going to be hand in hand with our customers to help you achieve the results that you're looking for. And about us. So we have two headquarters. We have one here in Troy, Michigan, um, which is from the DCS side of things and has a metrologic focused location at Wixom. Additionally, the metrologic side headquarters is in Grenoble, France. And together we have more than 50 years of experience with a focus in 3D metrology, tolerance analysis, quality data management, all of the products and services that you've come to expect from us. Now, one important aspect is that Metrologic DCS is a part of the Sanvik Group. Now, the Sanvik Group includes other major software developers like Mastercam, Verisurf. And what this means to you is that it's going to promote the connection of these softwares to make it easier for you to move your data and for you to create linked processes throughout your manufacturing system. It also means that we have a larger worldwide presence so that you'll be able to get services, training, expertise, and help locally where you are and in your local language. Together, we service every manufacturing industry from aerospace and defense through power and energy, consumer electronics, shipbuilding, even fusion and power creation with the E-Tier project in France. And what we are going to be providing now as a combined company is a complete end-to-end solution from the design all the way through to manufacturing. And what this looks like, if I can get our GIFs going. There we go. What this is going to look like for you is the ability to optimize your designs early in the process, showing you not only where you might have risk factors in your product for manufacturing, but also showing you where you can optimize and make improvements. This being fed into Planner, which is what today we'll be focusing on, will allow you then to set all of your inspection based on your model, following along that model based enterprise approach. Silma, of course, offline inspection and programming and simulation, and then Metrolog, as all of you have come to expect, will still be the powerhouse it is for inspection, reporting, and single part analysis. And all of this data can be fed up into QDM or Quality Data Management Program, which then allow you to monitor it in real time, create reports, dashboards, even inline inspection screens so that as you're producing parts, you can see in real time whether they're meeting your specifications or not. And this can be fed back into 3DCS for root cause analysis and problem solving, utilizing that digital model. Today, we've got two presenters to showcase the first part of the end-to-end solution, the 3DCS and Planner portion. Vishnupriya Vijay Kumar from our technical support team focused more on 3DCS, and then Clement Martinez, application engineer from the Metrolog side, will be showcasing Planner today for you. All right, so this time I'm going to let Priya take over. She's prepared some material for us to showcase exactly how 3DCS is going to prepare these components for inspection.
Good morning, everyone. I'm Vishnupriya. So I'll be doing the 3DCS software demo today. So before we get into the actual demo, I have a couple slides here to go over so to get you familiar with our 3DCS software. So what is 3DCS Variation Analyst? So 3DCS is a virtual assembly simulation software that predicts and it also controls the manufacturing variation even before the parts or the assembly get into the production level. So we as a software, we are integrated with the leading CAD platforms, which includes CATIA V5, 3D Experience, NX, Creo, and SolidWorks. And we're also available as a CAD neutral standalone version. So why we use 3DCS? To explain this, it's nice to have a real example of a real world challenge of variation. So no part is perfect. Like any part that's output from a production will have variation on the features, which includes hole, pin, surfaces, or fixtures. So when these variations stacks up, it leads to a lot of rework and scrap, or because all the failures end up as scrap parts. And which now when you have to do a lot of reworks, that kind of delay the overall production process, which kind of end up with a lot of customer complaints. So what's the real challenge here? So these issues that we discussed, they are all often discovered after the parts are built. So at that point, when you're trying to do any changes, any reworks, it's going to double up the cost. And then also you can't meet the timeline. So this is exactly where 3DCS comes into picture. So whatever we discussed, all these failures can be predicted and also this variation can be controlled with our software even before the production is actually started. So what 3DCS really does? So 3DCS answers three critical real-life questions. So the first one, will my parts assemble correctly? If not, so where is this actual variation is coming from that's affecting my assembly failure? And third, what is the most cost-effective way that I can do to fix this without compromising the quality? So how we do? So we get the CAD model for accurate digital assemblies. We apply the real-world tolerances to the parts and fixtures. And we also define how the parts need to assemble by mimicking the real-life assembly sequence and run the statistical simulation, which is the Monte Carlo simulation, to mimic thousands of realistic builds. And finally, we provide the visual results and also the contributor analysis is where we pinpoint exactly where the problem is happening even before the production is started. So with that said, I'm going to switch to the demo. All right, so I have 3DCS here integrated with CATIA V5. So 3DCS software coming as analysis add-on workbench. So here for this demo, I have an injector assembly where we get the geometry from the CAD. So this is a CATIA model, but this applies to any CAD platform that 3DCS is integrated with. We get the geometry from that respective CAD. So once we have the geometry, we start to add the 3DCS data, which includes the tolerances, the assembly sequence, and the measurements. All these informations are added through the 3DCS tool. So first, we have this 3DCS model navigator. In general, this mimics your CATIA tree, where we get the tree structure and the part name information from. And now we start to add our 3DCS data, which includes all these subfolders that you see within the part, where you can see the GD&T, the measurements, the moves, and bunch of feature folders. So these are all the data that's being added by by the 3DCS tools. So when I say we add the 3DCS information, so whenever a CAD surface is selected from the geometry, we create a mesh on that surface and we use that mesh for our analysis. So to show that, if I turn on the mesh, so now you can see these bunch of lines on all the CAD surfaces. These are the analysis mesh, or the mesh that 3DCS creates on the actual CAD surface, and we use that to simulate and produce our final analysis results. To understand this more clearly, so if I zoom into one of our part here, and if I go into the GD&T folder of this part, so I have a bunch of GD&T defined for this part right here. So you can see by now clicking on a GD&T, it highlights that mesh on this part. So say, for example, if I open one of this GD&T, I have defined it. Defined a surface profile on this with a range of 2.54. So if I zoom in here a little bit and I'm going to hit deviate. So what it does, it's going to show the variation that I have applied by the GD&T dialog visually by showing how that mesh is going to vary. So in this way, a user will have an understanding how that specific feature will vary for the applied GD&T. So then similarly, if I zoom out a little bit and close this dialog, get this out of the way, and deviate it again, so you can see the deviation is happening on all the surfaces that has variation in it. So now if I come in here, zoom into these surfaces, I can see there is a variation being applied on all these meshes. So wherever the mesh is moving or deviating, you can tell that these surfaces have tolerances being defined by 3DCs. So now after I have the 3DCs, I have the tolerance defined. So the next step is to define the assembly sequence. So here, if I come down in the tree, I have a folder that's called moves, where I have defined all the move sequence on telling how the parts need to assemble with respect to the other one. So if I come in here, I hit the animate button. So this will visually show you how the move has been defined, or the assembly sequence has been defined within the 3DCS. So what you see right now on the screen is nothing but the animation of all these set of moves that's being defined here within the move section. All right. So that's how the parts are getting assembled, and this is mimicking your real world assembly sequence. So with that, so now the next thing I need to check, or next thing that I've created, is the measurements. So now I have assembled the model, and I have the tolerance department. So now I want to check if my assembly is building and it's meeting the expectation by creating some measurements for the specific measuring locations. So for that, if I separate the parts, I go down in the list further, you can see there, these are the list of measurements that I have created. By just clicking on each measure, it shows where the measuring locations are. But if I had to go pinpoint one specific measurement here, so I need to just take a quick cross section of the model. If I come in here, here, all right. So now if I assemble the model back again, get to one of the specific measurements, so I'm trying to get to the gap measure here between these two parts. So if I zoom in here, I'm looking for this gap between the orange part and the pink part. So at this position, if I deviate, so you can see the gap, or the gap between the orange part and the pink part growing and shrinking. So this is the mesh. This is the gap I wanted to check. And checking meaning I wanted to know that there is no interference is going to happen between these two surfaces. So if I get into this measure, the measure dialog tells me the features that I'm using for this specific measure. And down at the bottom on the specification limits, and I have defined that none of my bills should go beyond 0, because which means that no interference should happen. So this is what I'm checking by this measure. So with that said, if I come back here, I'm going to nominal build and run the analysis. So this run analysis dialog is going to run the Monte Carlo analysis and also the contributor analysis. The number here that I have specified, it's going to mimic the number of realistic builds of the assembly, but this, I'm simulating it virtually by doing this analysis. So if I go ahead and run this, all right, so now I have the analysis results for all the list of measurements that I have in the model. So if I go into the one that we are looking for, so it's the gap measure between the plate right there. So now this for this measure, what the results saying is, so out of 10,000 bills that I ran, 17% of the bills failed, meaning I see a crash that's happening and the two surfaces were interfering 17% of the time. So this is what our Monte Carlo analysis results is saying. And down at the bottom, we have the contributor analysis. This is nothing but it's listing out the list of tolerances or GD&T that was contributing for this specific gap measure. So it's saying the first one in the list being the top contributor, and you can see the percentage is gradually decreasing, meaning these are the impact of each and every tolerance on this specific measure. So this is the information that we give to the user, so from which the user can now decide how they wanted to take it forward. So if you wanted to improve your results by reducing the number of failures, the user can go ahead and tighten up the tolerance and give this information back to the design. So when this information is fixed, I go back to the model, go here. And now the reviewed and the updated GD&T information that we got after running the analysis from 3DCS. So this data would now be updated within the part. So now the part GD&T information would be updated based on the results that we got. And now this part, this fixed part information would be proceeded and given to the production team for the next step. So that's where I end my demo. Thank you.
All right, fantastic. Thank you so much for that, Priya. Just give me one moment while I reset. All right, so perfect. All right, this time we're going to be passing it over to Clement. Give me 1 second, Clement.
Yes.
There we go. Thank you so much. I'm going to mute myself.
Yes, you can. Thank you. Thank you, Ben, for the introduction, and thank you, Priya, for the presentation. So now focus on Planner. So Planner is an offline software and one of the first step to start the manufacturing process. And with Planner, you will be able to prepare your work and plan your inspection. So be able to define all the characteristics to measure, prepare all the view, all the alignment, and prepare your report to be ready for the next step, the programming step with Sigma. So you will optimize the 3D inspection planning directly from the CAD models, because with Planner, we are close to the design department. So next slide, please, Ben. So why use Planner? The first one is to facilitate and consolidate the preparation phase. So with Planner, you prepare all your inspection faster with less effort, and you get a clear, organized process. The number 2 is to save time and digitalize data. You save a lot of time because all is digital, no more paper, and you can move automatically to the other application, to the other team, what we call a global package in only one digital document. Number 3, you will increase your productivity using PMI, so the product manufacturing information. So you will boost your productivity with using PMI and industry with the industry standards. Number 4, Planner is a easy to use interface for all the operators. So the interface is simple and any operator can use it quickly. So in short, with Planner, you can work faster and reduce mistakes. Thank you. Can you move, please, to the next one? Thank you. So the first step when you open Planner is to open and import your CAD. So you are able to import any CAD file. You are free to import any CAD format to stay full compatible during your inspection flow. Yes, just before, maybe too fast, but you are able to work with Creo, with EGS file, with CATIA in this example, SolidWorks maybe. So next slide, please. So now when the CAD is open, the next step is to define all the characteristics to measure. So reminder, we are close to the design department, so we know what characteristic is important for my inspection. We have 2 solutions. The first one is to use a CAD with PMI. So you just have to decode all the PMI. So you will get all the characteristic, all the datum, all the GD&T, and maybe all the view. If you have a view design on with CATIA, so you can decode easily in one click all the features. If not, it's not a problem. You just have to define yourself all the cylinders, all the plane, all the datum, all the GD&T from the 2D drawing, and you have to set all the information you need yourself. Next slide, please. Now focus on GD&T, so it's an important thing now. We have a clear interface to create your own GD&T. We have a quick access to the standard to use, to the tolerance, to the calculation to set. And we have a Windows automatically update depending your setup. So it's easy to understand what's happened in the 3D in the Windows. And sometimes we think it could be not easy, it's complex to understand. So we give you the possibility to check with the features relationship all the information about your GD&T, about the datum, depending on your GD&T. As you can see on this screen, you have the position GD&T, and you have all the information, all the datum, all the plane and cylinders depending to this position. And we have also the scan GD&T to see the result at the end of the inspection, to see if the GD&T PMI is semantic or not. And at the end of the inspection, all the GD&T result will be on this area. Next slide, please. Thank you. As I said before, if you don't have PMI on your CAD, it's not a problem. You can create your own PMI easily with Planner with only one click. So the first step is to create maybe a plane, assign a flatness to this. And at the end, on the flatness, only one click to the flatness, create the PMI. And you can also create the ballooning associated to the PMI to add, for example, a chart number, very important for the manufacturing process. So now about the alignment, you can create with Planner all the alignment you need. it's automatically update on the 3D view. So for example, you can create alignment on a plane and circle and move, for example, the orientation on X, and it will be automatically update on the 3D view to help you to understand what's happened. It's time now for the first demonstration with Planner. So you can, yes. Thank you.
With Planner, import any CAD file, any data such as CATIA, SolidWorks, NX, Creo, STEP, and so on. This keeps your workflow fully open and compatible. The CAD is instantly loaded with all PMOs if your base file contains them. Increase your productivity using PMI following the standards too, and avoid human errors. With the inspection plan collector, decode with only one click all the features, GD&T, and views. All the features are now on the features database. If you don't use PMI now, don't worry. Define manually all the features and characteristics that you will measure next. Define the type of features and simply click on the CAD and the job is done. In order to comply with the 2D drawing specifications, easily assign a datum to your features. Here, let's assign datum A to my plan 1, for example. Select from the list which tolerance to create, and you are free to choose the elements in the 3D view or the database. Now let's focus on the tolerances module. Easily define your tolerances either from the list or from the tolerances menu. Easily define your flatness, circularity, and position tolerance. Click on the 3D view or in the database to select the tolerance elements or your references. You have control over the tolerance value, the association criteria, such as least squares, Chebyshev, etc., and all other calculation parameters. You are in full control of the process. All the GD&T are available on the features database. Edit them at any time if necessary. With Planner, add PMI, Product Manufacturing Information. With only one click for a better visibility, add the datum and tolerances attached on your CAD. For even faster comprehension, add ballooning very easily. Ideal for finding your way around later. Relaunch an inspection plan collector so that the number is correctly decoded. You will find it in the results window attached to your item. Create any alignment with Planner. Based on reference features, orient and position your alignments so that everything is ready for the programming stage. Find and edit these alignments at any time in the database. The display is dynamic, allowing you to see in real time how your alignment will be positioned on your part.
Yes, thank you for this first demonstration. Now focus on the prepare view and stickers. As you know, decision making is important. The target is to understand quickly what's happened. So you can create your own view, your own stickers with a detailed view. For example, if you want to understand better what's happened during the inspection, you can create and customize as you want the view and stickers. For example, create a specific view for all the cylinders result, a specific view for all the GD&T, and add the callout of each GD&T. And as you see on the bottom, on the right corner, you can create a specific view, detailed view, to understand what's happened for your cylinder and when the inspection will be done. the view will be automatically updated with the real result. Next slide, please, Ben. And with Planner, you can also prepare your report. You can customize, like the stickers and the view, you can customize as you want. So prepare all your result table, all your background, all your view. And at the end of the inspection, like the view, like the cylinder, the report will be automatically updated. So you have all the view, all the stickers, all the characteristic, all the reports embedded in only one document. And this document will follow all the steps of the manufacturing process. With Silma on the step number 2 for the programming inspection, programming creation, and after on the step what we call number 3, when you execute your inspection on the real CMM. Next slide, please. And now a quick focus on the export. So we have two possibilities about the KIF. The first one is to open a KIF document with the working session, add some information in this KIF document. So, for example, some GD&T, some PMI, some ballooning. Export with a merge. So we merge all the information you import before and merge with the information you had with Planner. And at the end, you have an enhanced KIF document. The option number 2 is to import a native format, like we did before with the CATIA format. You can, with Metrolog, understand all the dimensioning data. So you decode all the PMI, all the GD&T. You will generate GD&T in PMI on the features database, and you can create a KIF generation for your inspection later. So we have two possibilities to work with the KIF format. Yes, it's time now for the demonstration number 2 about the view and report.
Planner allows you to create precise stickers and clear views to prepare your inspection report. Adapt and customize each label as you see fit. Drag and drop elements into the 3D view. Edit a label to display the information that is important to you, diameter, shape defect, and apply to all labels. You are free to change the font size, color, absolutely everything. Even save this profile for your future reports. When this is done, create a view that will be used for the inspection report. Create the number of views you want for a complete and quickly understandable report. In this example, a view specific to cylinders has been created, but let's also add a view for geometric tolerances for quick decision-making once the part has been measured. One of the final steps is the control report. Here again, you have the freedom to customize the background of your report however you want. Add any photo, any information, any variable. Add the features and views you want and edit the table if necessary to display only the information you want. Drag and drop the desired elements or use the shortcut to generate a unique results table. The report is the final step. Planner offers the possibility of creating the report so that those in charge of programming and control no longer have to deal with this task. You are the one who knows your CAD and knows which features to highlight. At the end, get the report you want. This inspection report will be saved in the inspection plan. Planner offers the ability to export data in several formats, including QIF format. From a native CAD format, CATIA in our case, Planner is able to understand and decode all dimensional information. Simply export your session to QIF format once all features have been decoded or defined. If another employee opens this QIF file, they will have access to all features, including GDTs. Planner can enrich files in QIF format. This file in QIF format includes a CAD and several PMIs. It can be opened directly from a single document in Planner with the Open Document menu. It is entirely possible to add features or GDTs. If we add flatness, set all the parameters you want for this flatness and export this information in always QIF format to enriched using merge data in the option of the export. As in the other example, if a colleague opens this document, they will have all the information, CAD and GDT, as well as the recently added flatness. A quick way to share and export your data.
And a quick slide on the next webinar. It's a quick teaser on the next webinar with always the same part. And the next webinar on Silma, we will create all the inspection, all the work cell, all the inspection program to inspect this part. So stay connected to be informed about the date of this webinar in the next month. I think it's the last slide, and maybe it's time for the Christian.